So in this video, we're going to look at trigonometric identities. All right, so we're asked to prove the following identities. Okay, so let's see what's going on here. So we have a left side, which is 1 over secant squared x. And on the right hand, we have sine squared x times cos squared x plus cos raised to the power 4 of x. Okay. So let's start with the right-hand side and see if we can reduce that, and then we'll work on the left-hand side. So the right-hand side, we have sine squared x cos squared x plus cos raised to the power 4 of x. So let's factor out a cos squared and see what we get. So when you factor out a cos squared x, we have in brackets sine squared x plus cos squared x. So this equals 1. This is one of our identities. So we have cos squared x times 1, which is just cos squared x. So this is our right-hand side. Now let's look at our left-hand side. The left-hand side is 1 over secant squared x. So what is secant squared x? Secant squared x is just 1 over cos squared x, which equals cos squared x. So therefore, which is our right-hand side, so therefore, since the left-hand side equals the right-hand side, we've proven our identity. That wasn't so bad. Okay, so here's another one. This looks interesting. On the left-hand side, we have the square root of secant theta minus 1 over secant theta plus 1. And on the right-hand side, we have cosecant theta minus cotangent theta. So again, let's start with the right-hand side, simplify it, and then we'll work on the left-hand side. So whenever we have cosecants, cotangents, and secants, the first thing we want to do is reduce everything or change everything to sines, cosines, and tangents. So right-hand side becomes 1 over sine theta minus cos theta over sine theta. So we have a common denominator of sine. So we can subtract our numerators, 1 minus cos theta over sine theta. Okay, so that's our right-hand side. Now, let's see if we can simplify this left-hand side. Our left-hand side is the square root of secant theta minus 1 over secant theta plus 1. Okay. This looks interesting. So secant is 1 over cos theta. So let's replace 1 over cos theta wherever we see secant. Okay. All right, so now under the square root, let's look at the numerator and denominator and put everything over a common denominator. Let's see how much space we have. Okay, so in our numerator, we have 1 minus cos theta all over cos theta. Okay. And that is all over 1 plus cos theta over cos theta. Okay. All right. I have to work a little hard on this side. Okay, so now we have our square root, and then we have 1 minus cos theta over cos theta. We're going to multiply by the reciprocal of the denominator. And this allows us to cancel out the 2 cos thetas. And what do we have? We have 1 minus cos theta over 1 plus cos theta, and we're going to take the square root of that. Okay, we're still not there. So I'm going to work under the square root, and let's multiply it by the number 1. But we're going to write the number 1 as 1 minus cos theta over 1 minus cos theta. Okay. And let's see what this gives us. So in the numerator, we have 1 minus cos theta all squared. In the denominator, what do we have? We have 1 plus cos theta times 1 minus cos theta. Okay, so in the denominator, we actually have a difference of squares. 1 minus cos squared theta. Okay, all right, we're gonna have to move over a little bit. Gosh, we're working really hard for this one. Okay. So again, in the numerator, we have 1 minus cos theta all squared. And in the denominator, 1 minus cos theta is the same as sine squared theta. So now we can take the square root of the numerator and the denominator, and we're left with 1 minus cos theta over sine theta. And remember what that equals? That equals our right-hand side. So therefore, we've proven our identity. Okay. That brings us to the end of our video. So if you have any questions, send us a message or give us a call. We'll be happy to help you. Thank you for watching.